Now we study uniform cost search. We have seen that breadth first search is optimal when all step costs are equal. But what if different actions have different costs? Such as from Arad, if you go to Sibiu, it takes 140 miles or kilometers. But if you go to Timisoara, it takes 118 kilometers. So they are not same cost. So for that, we need uniform cost search. Now, how uniform cost search works? Uniform cost search expands the node with the lowest total path cost. Remember, lowest total path cost, denoted as G of n. Instead of a FIFO queue or first in, first out queue, the frontier is a priority queue ordered by the path cost because we need the lowest or least cost. So we need a priority queue which will sort among all the fringe or the frontier nodes and select the one with the lowest total path cost for expanding. So this means cheaper paths are always expanded before more expensive ones. There are two important differences from BFS. First one is that the goal test is applied when a node is selected for expansion, not when it is generated. This prevents us from accepting a suboptimal path too early. So if there is a longer path, we will actually not select it, or will replace it with a cheaper path. So number two is if a better path to a state is discovered, the algorithm updates the frontier with the new lower cost version. Now let's consider the same example we talked earlier, the Romania map. Suppose we want to travel from Sibiu to Bucharest, which is here. Now we can go through Râmnicu, Vilcea, Pitești, and Bucharest. Or we can go to Făgăraș and then Bucharest. So the frontier chooses Râmnicu Valley, Vilcea first because it's cheaper. It's 80, and from Sibiu to Făgăraș is 90. Among these two ages, this is cheaper. Now expanding it adds Pitești. So now when I expand it, it will add Pitești with a total cost of 177. Okay? This plus this, the total cost. Now, Pitești will be 177 cost, but now Făgăraș will be at 99. So Făgăraș is kind of in the queue earlier than Pitești. So then Făgăraș will be expanded rather than Pitești, and then we will find that there is a cost to Bucharest which is 99 plus 211, which is 310. But uniform cost search does not stop yet, it continues. It then expands Pitești, which is the next cheapest, and then gives a better path to Bucharest with cost 278, which is less than 310 through this path. So this path is 278 total. So this path will be the solution instead of this path. This shows how uniform cost search ensures optimality. So why it's optimal? Two facts guarantee its optimality. When a node is expanded, we already know we have found the cheapest path to it. This has some relation with the Dijkstra's shortest path algorithm. Only that there it found shortest path from one source node to every other node in the graph, but here we find from a particular source to a particular destination. So the optimality, the reason is, one is that when a node is expanded, we already know we have found the cheapest path to it, and the second is since step costs are non-negative, extending a path can never reduce its cost. So when you are extending a path, we are basically adding to the cost. So like when we expand Pitești to Bucharest, then we kind of add another edge with some weight to that path. Together, this means that the first goal expanded must be the cheapest possible goal. Okay. So now what are the performance and the limitations? What about completeness? Yes, as long as every action cost is above some small positive value, no zero cost infinite loops, then it's complete. Okay. What about optimality? Yes, we already said that always finds the lowest cost solution. And then what about time and space complexity? Let C star be the cost of the optimal solution and let each step cost at least epsilon. Then worst case complexity is about big O of B1 plus floor of C star divided by epsilon. And then this can actually be worse than BFS, okay? Because the search might explore lots of tiny cheap steps before considering costlier but more direct ones. That means we go through many smaller paths before we actually go through the direct and more acceptable path. So when all steps costs are equal, uniform cost search actually becomes same as BFS. But it does a little extra work since it expands all nodes at the goal's depth before stopping. Okay, so it will expand all the nodes at the goal's depth before stopping. So this is important. So now uniform cost search is a generalization of BFS that works with arbitrary step costs. It is complete and optimal, but can be expensive in time and memory if there are many low cost paths. So you guys should check if you can expand Arad to Bucharest this pathfinding using UCS.